Hello, everyone. Today, me, Siri, Shubham, and Rohan are going to present to you our project for SER 421. Our project's topic is messaging-oriented middleware. So the aim and the goal of this tutorial is, so that you can learn about MOM, and we are mainly focusing on Kafka and JMS. The learner should understand what they are and how they can be utilized, and they should also understand the history of the MOMs. The learner should understand the depth of the architecture as well as how to implement both Kafka and JMS. They should understand in depth the internal working. Now we'll move on to the introduction. Messaging-oriented middleware is a key part of the ESB architecture. It helps, you can understand how messages are being communicated. So this provides a brief introduction, and this image describes how the message-based communication takes place when two applications interact with each other.
Continuing with the JMS part, JMS is Java Messaging Service, which was developed by Sun Microsystem in the year 2001. Java stands for Java Messaging Service, which is a messaging middleware platform which is used to send and read messages on the Java servers. Messaging is basically exchanging of information on two applications or servers, and there are two ways in which it can be done. The first way is point-to-point messaging, in which a JMS producer will send a message to the queue, and the JMS consumer will consume the same message from the queue. Once the message is consumed, it will be deleted from the queue. The other model is the publish-subscribe model, in which a client or a producer sends a message to a topic, and it can be consumed by different consumers. JMS follows the architecture. There are two JMS API offered. One is JMS 1.1 and 2.0. And there are few objects which will be created for JMS API. Those are connection factory, connection, sessions, message producer, and message consumer. This image explains the classic API or JMS 1.1 API. And this image explains how we create JMS objects in JMS 2.0 API. We have already discussed about JMS message. JMS message is basically comprised of three parts: JMS header, JMS properties, and JMS body. In JMS headers, we use to identify the messages by using different tags, which are message ID, correlation ID, expiration date, and all things. JMS properties is also similar to JMS headers. These are additional properties which can add it to be the message. Finally, JMS body, we have 5 types of messages which can be included in the JMS body payload. Those are stream message, map message, text message, and object message, and byte message. Then we have explained the two working model of JMS, that is point-to-point messaging and publish-subscribe messaging. Finally, in the end, we have described how to send a message to a queue using Java messaging service. We are using ActiveMQ server to host a queue. And we have described all the ways how to install a JMS service or Docker on which you can host your ActiveMQ server. And finally, there are steps in which we can send a message to the queue. And here I have described a basic connection objects and basic code, how to connect to an ActiveMQ server and how to send a message. Finally, in receiving message section, it will be similar to the sending message, and we will have to create those similar objects, but a message consumer at the end, which will consume the message from the queue. In the demo section, we have included a video on the working of JMS by providing the sample codes. Now, passing on to Kafka.
Yeah, could you navigate to Kafka? So Apache Kafka is distributed event-driven and stream processing platform, and this is developed by Apache Software Foundation by LinkedIn in 2011. And then the message domains, there are two message domains in message middlewares. There is point-to-point and publish-subscribe. This Kafka will come into publish-subscribe model. So there can be any number of producers, and there can be any number of consumer groups. In that consumer groups, there will be consumers. Producer will be sending the messages to the Kafka server or broker, and the consumer can consume it. Yeah, architecture. So the elements of Kafka will be publisher, messages, Kafka server, and consumer group. We will be using Apache Zookeeper, as this Zookeeper will store all the topics data and the consumer info on how many times he clicked it and what all messages he read. And we will be using 4 Kafka APIs: producer API, consumer API, connector API, and stream API. Yeah. So I have briefly I have included every detail of how to install Kafka using Docker and how to install Zookeeper using Docker. Yeah, so these are the POM files. The dependencies should be added, and if you scroll down, this will be the scroll up, Shubham. This is sample producer. This is the code, and this is sample consumer POM file, and this is sample consumer file. So I've explained in detail in the Kafka project demo. Yeah.
Okay.
Thank you.
Yeah, we have provided all the references, for all the information that we have used. So in the point of view section, I have described the analysis of JMS and Kafka. So JMS and Kafka are, very relevant to the current industry and the amount of communication that is happening. So whenever you do an analysis, our personal opinion is that, one is not better than the other. There are pros and cons in both. And on this page, I have described the different questions that you need to ask before choosing to use either Kafka or Apache. So you can ask questions like, what is the load of consumers and producers? Do your messages need to be filtered? Do your messages need to be ordered based on topics? Does your application need to be scaled massively in the future? And would you like any abstraction while handling the data? Below, I have also reasoned out what are the answers to these questions and what you need to use when. So always doing an analysis of the scenario is helpful, and one is not better than the other, but it's based on the situation. Moving on to additional resources, here I've listed all the additional resources that you can use, and these are all resources with the right information, and they are verified resources, so you can always go ahead and learn more.
Yes.